Well guys, disaster struck. The Roadrunner, which I'm not supposed to work on, has developed a pretty bad tick. So I'm going to make a video on everything that you have to do to diagnose an engine. And then I'm also going to show you how to advance the timing, prime the oil pump, flatten an oil pan, and get the car ready for winterizing and storage. All tools can be found in the links in the description down below. Now this is an older engine, so not all of this might apply to you. All engines function similarly, so there will be a lot of overlap with this engine, but specifically this is a 383 Chrysler Mopar engine. It's a big block, so it's going to be almost identical to a 440 and a 400. Now this engine is carbureted and distributed. Here are some other general symptoms of other common engine problems that we're not going to discuss in this video. I can tell that the tick is coming from the passenger side of the engine. Sure, it's not a loose belt or tensioner or something. When we go to diagnose the engine, the first thing you're going to do is check the engine codes if there are any, or if the car is equipped with a computer. This car is not, so we're going to have to do it the old-fashioned way. It sounds like it's happening every combustion cycle. It could be air, fuel, spark, or compression. If we're talking about air, then it could be a bad valve, a lifter going out, a valve spring broken, maybe an exhaust leak, or a cam lobe. When it comes to fuel, this is a carbureted car. It could be the carburetor or the fuel pressure, or it could be an injector. When it comes to spark, it could be the spark plug wire, the spark plug gap, or the distributor or ignition coil, depending on what setup you've got. And with compression, it could be a valve again, or a crack, or maybe something worse. Compression could also be low because a piston ring is gapped too wide or is damaged. And worst comes to worst, it could be rod knock. You could have a bent connecting rod or a connecting rod bearing going out. We're going to systematically approach diagnosing this car. So I'm going to rearrange this list and then reprioritize it from the easiest to the hardest things to do to diagnose your engine. I'm not going to perform all of these, but I'll provide a timestamp of each one of the things that I do address on the left. So let's get started on this list. First thing you're going to want to do is check the engine oil pressure. If it is low, then you should not run your car anymore and you should get it towed to a shop. Some more detail on that later. Then test if your car performs normal or well under acceleration. If you think you have rod knock or a bad bearing or head gasket or low oil pressure, you should not do this step. Since this is carbureted, we don't really need to test the fuel. All of the cylinders get a portion of the fuel and air mixture that is produced by the carburetor. So if one cylinder has fuel, then the other cylinders ought to as well. If it runs and performs fine, then it's probably not fuel. My car does run, so I can tell that it's getting fuel with cylinders. So it seems the reason that fuel would not be to blame. On an injected engine, you might want to test each injector individually. If there's blue smoke coming out of the exhaust, then you're burning oil, meaning oil is getting into the cylinder somehow. There could be a crack or a gasket leak. If the exhaust cloud is really white, then you're burning coolant, meaning coolant is getting into the cylinder somehow, probably from a crack or a bad gasket as well. If there's black smoke coming out of the exhaust, then it's likely that there's too much fuel being entered in. Could be an injector that's stuck on or it's tuned poorly. If you don't have a code scanner, you can go down to any local auto parts shop and they should be able to check your engine codes for you. My car is not exhibiting any of these last couple of behaviors at all. One of the easiest ways to diagnose an engine is to change the oil. If the oil comes out and it's kind of frothy and light brown, then coolant is leaking into the oil somewhere in the engine and you have an issue. Probably a gasket problem or a crack. I decided to drain the oil and guess what? There is some shrapnel in the pan. Thankfully, none of it is magnetic, so that tells me it is all bearing material. I decided to cut open the oil filter to see if I could find anything else. Don't use a cutting wheel to get these things open because then you'll spray a bunch of metal into the oil filter and you won't really be able to tell if it's from the engine. Instead, I used some tin snips and a drill to get a hole started. And actually, the oil filter was almost 100% spotless. So that means that everything's probably just in the bottom of the pan and it's not getting picked up. The worst case scenario is that it could be some sort of rod knock. And I'm not sure that's what this is, but for the purpose of the video, I'm going to investigate this a little bit more anyway. Rod knock occurs when the bearing spins in place and gets unseated and then grinds itself apart. And so every time it rotates, it will knock. It makes a pretty distinct sound every time the cylinder fires, and it creates a gap in the connection between the connecting rod and the crankshaft. If you lost oil pressure, it could be a sign of a bearing has gotten worn out and the gap is too wide inside the journal, causing the oil to just spill out and the whole oil system to depressurize. On a Mopar big block, particularly cylinder number 7 can have issues with this. There is a chance that the oil pressure will not really drop if you do have rod knot. It could happen if the oil is cold or really thick type of oil, or if the bearing clearances are somewhat okay. I want to hook up an external oil pressure gauge to see what your actual oil pressure is at. The manual for this Mopar big block says it should be 45 to 65 psi. Rule of thumb on some old cars is the gauge should probably be about halfway up. Last year I started this thing up and the carburetor was stuck in full throttle. And it appears that I actually have plenty of oil pressure, so I'm guessing that when it had that hard startup that it just wore out some of the thrust bearing, and that may be okay. But later on in the video I'm going to change the oil, run the car some more, and then change it again and see if there's any more bearing material in the oil, and measure some of the bottom end clearances. Please make sure you fill your car back up with oil and reinstall the oil filter if you drained it in the last step. There may always be multiple things going on with the engine at the same time, but I'm still going to continue to diagnose this noise. So I'm going to start with the spark plugs. One of the easiest things to check is the ignition. Might be a good idea to get yourself one of these mats you can put down on a car fender so you don't have to scratch up the car with your belt buckle or anything. Links in the description. All you do is unplug each spark plug wire and see if the noise goes away, and that will narrow it down to one specific cylinder. And it happens that cylinder number 8 spark plug wire actually does make the noise go away. And this might not be the same case for you, but this is a very, very good clue for me. And I decided to take off the exhaust manifold, and guess what? It is a exhaust leak. This manifold's kind of difficult to get off, but it slid off after plenty of elbow grease, and after all of that effort, it was just a little leak in my exhaust gasket. I had to clean off the block in my old headers. I used a little grinding wheel to do that, and razor blade. Decided to order this different style of gasket that doesn't actually come apart, and hopefully this will not happen with this type of gasket again. So in case this doesn't fix noise with your engine, then I'm going to keep going and diagnosing the rest of this engine. If you unplug it and on one of the cylinders the noise doesn't change, then that might be an indication of a misfire, which would apply to the next couple of tests here. And we're going to test air, fuel, spark, and compression in the easiest order. So we're going to check the spark plug wires for some burns and arcs first. Then I checked the spark plug wires and they were all right. I turned the lights off with the garage doors closed and looked to see if I could see any arcing in the engine bay, and there wasn't any. Then I pulled off the distributor cap to see if anything was corroded underneath, and it looks brand new. In case you get mixed up, this is the firing order and the position on the distributor of what spark plug wires connect to which. Then we're going to test the spark plugs for spark. So that this thing doesn't fire, I actually take some vice grips and I pinch off the fuel supply hose for the carburetor. You might want to let it run out of gas for a little bit before you try this. You can change every spark plug out, or you can test each spark plug by pulling it out, and while the engine is cranking, ground by contacting the metal part of the spark plug against the metal block. You might want to turn the lights down to see if you can see the spark. You might want to replace your spark coil if none of your spark plugs produce a spark. You also could have the wrong plugs in there, so make sure that you have the correct ones for your engine. On more modern cars, you may have a computer ignition problem where the computer is not giving a signal to the spark coil, and beware that wiring is always a factor as well. Last thing you might check on a spark plug would be the spark plug gap. The only thing you really need to know about spark plugs is what torque to tighten them to and what gap to set them at, and use the spark plug gap tool like this. While you're checking out your spark plugs, be sure to refer to a chart like this one to ensure that you've got enough fuel, you don't have too much fuel, and you're not burning oil. You can kind of do this one in conjunction with the last step, but then we're going to test compression. While you're pulling the spark plugs out, if you do check those, then it is a good opportunity to check compression by plugging in a compression tester where the spark plug was, and then cranking the engine with the main ignition coil disconnected. Just make sure they're all about the same. All of these compressions look within about 5 from each other on this gauge. They're all reading about 120. After testing all the cylinders, it seems that both spark and compression are not to blame. Then you might want to test fuel pressure. This car has a mechanical fuel pump, and going back to earlier in the video, again, there's not much to test with fuel. If it gets it, it gets it. If it performs fine, it's probably getting plenty of fuel. You can usually find a fuel pressure testing port on a fuel rail on a more modern engine. This car does not have fuel injectors, but you might be able to test those individually on yours. There are some pretty good videos that already cover this. If it's not fuel, spark, or compression, it could be air, in which case we would test the valve train now. In order to know that air is properly getting into the cylinder, all we really need to know is that the valve is opening up properly. Now we're going to remove the valve cover and look at the height of the valves when the car engine is cranking over. So I took the valve cover cap off and I can look at these. Or you can remove the valve covers entirely. This is was pretty easy to do on older engines like this, but modern cars it might be a little more difficult to get stuff out of the way. You can turn the car over. If one of the valves doesn't go as high or low as the other ones when it opens and closes, then you may have a collapsed lifter or a bent push rod. Valve spring could be broken, or a bad cam lobe wearing down. All of these valves appear to be going to the same height, so I don't think it is a valve issue. You can actually pull these lifters out with a special tool without having to remove the cylinder head. But since none of these valves look like they're operating poorly, I don't think I'm going to do that. In order to ensure your valves are adjusted correctly, you can spin the push rods. When each rocker is at its peak, see if you can spin it. Or sometimes they're a little tight. Mark with like a silver Sharpie or something a line on each push rod, but they should spin after every couple combustion cycles when the car is running normally. If it's too loose, then you probably do have a lifter or cam lobe issue. There should be no gaps in there and your push rod should be tight. You can also take off the rocker and use a Sharpie on the top of the valve to color it in, and then put the rocker back on, turn it over a few times, take it back off, and the line from the rocker making contact with the end of the valve should be about on center here. And it might vary depending on your setup. Not all cars have adjustable rockers, but this is a way to tell that your valves are adjusted correctly. If something may have caused damage to the engine because of the wrong fuel or revving too high, then you might want to lower the timing on your car, or at least tune it and adjust it correctly. Lowering the timing will decrease the chance that you have pre-detonation, or in other words, a knock or a ping sound in your cylinder that could damage your rods and your rod bearings, as explained earlier. On old engines like this, there's a way to do it mechanically. Once you get the car running, go ahead and crack the timing light out. Connect the timing light up to the battery and put this sensor clamp over the spark plug wire from cylinder number 1. Then turn off all lights in the garage. I disconnect this vacuum hose to the distributor because I don't want the vacuum affecting the timing while I am tuning it. Start up the car, and while it's running, flip the switch on and point the timing light at the crankshaft pulley. Here you can see a couple of factory markings for where the timing is, and I'm going to advance this thing so that that marking is showing up at 10 degrees advanced. So you've got to loosen up the distributor here and physically rotate it. It might be a good idea to mark with a Sharpie where you end up being so that you can quickly put it close to where it was if you do have to adjust it again. Then once you get it where you want, just tighten up the distributor again. You know you've gone a little bit too far when the car starts up and kind of jerks on. You're not far enough if it's real sluggish to start. And don't forget to put that vacuum line back. Because earlier I had some shrapnel in the oil pan, I am going to clean it out and inspect the bottom end too. I'm going to drop this oil pan. I need to disconnect this steering linkage. It has 4 castle nuts on it that I'll have to remove first. Make sure to carefully remove this so that the oil pan pickup tube does not get bent. So here's the bottom of that oil pan. There is a little bit of extra flakes in here, but not really that much though. You can measure your crankshaft end play by taking a screwdriver and then pry the crankshaft against the mains here so you can move it back and forth. Bottom it out in each direction, measure each one. Put in the fuel gauge in the middle here. So my feeler gauges indicated it's slightly over the tolerance in the factory service manual. And that's possibly because maybe it was a thrust bearing that got worn down. I am pretty hard on the clutch sometimes. When you press on the clutch, it actually forces the crankshaft into the thrust bearings. When I was investigating in here, I did notice that the center thrust bearing on this thing doesn't seem to be seated quite right. There's 2 semicircle halves of this thrust bearing, and they don't seem to be lined up the best. When you install these, you're supposed to tap on the crank forward and backwards to line them up, and maybe that never happened here. So then let me know what your thoughts are about this in the comments below. Check all of your side plate of the connecting rods. I ended up being between 16 and 18 thousandths apart on each one of these spaces in here, and the manual definitely says that they should be a lot less, but this engine was reworked at a engine shop, and I don't know what specifications they reworked it to, and I'm assuming they wanted to open it up a little bit more, because I think usually machine shops will use a little bit looser tolerances to make a performance engine, but because the side play is a lot greater than the end play, then there is plenty of clearance for these connecting rods to move around without bottoming out on anything, so this might be okay. If you really wanted to get fancy, you could take the caps off and check the rod bearing clearances with some plasti gauge, but I don't think I want to do that. I'll take off cylinder number 8 just to see. You might want to mark which bolt came out of which hole. There is a little bit of a mark on this journal here, and if you run your fingernail over it, it does slightly catch, but I don't think this is enough to warrant repolishing this thing. And running my finger over the bearing is totally smooth and fine here. Don't press too hard on the bearing because they are very, very soft. Then I decided to put some Comp Cam's assembly lube oil on here. It's just a sticky oil. Make sure that it stays oiled when you start it up, and make sure that this bearing is seated properly. There are some notches on the inside of the connecting rod ends where the bearing should line up with. Make sure you tighten the connecting rod bolts to the factory specification of torque and put both bolts back on the original hole that they came from. It looks like the guy who put this together bolted this thing down too hard with too many layers, so it warped all of the bolt holes and the pan's not straight at all anymore. So I hammered some of the holes back a little bit straighter, and then I tried to bend the pan back into place using this 2x4. Then I used my professional grinding stone here to try to grind it a little flatter and clean off the oil pan really thoroughly when you're done with it. And I found out why this oil pan was leaking. The guy that had put this together before had put 2 gaskets on here with a windage tray, and in between each layer there was this orange RTV. So there's layers and layers here that causing leaks. I found that using WD-40 on this orange RTV actually makes it very pliable, and it almost just falls apart after being exposed to it for a short amount of time. So go ahead and soak anything that you've got in some WD-40 to get this old orange RTV off. Or if you don't have a lot of WD-40, gasoline does the trick too a lot of the time. I got an all-in-one gasket and windage tray. Just make sure it's clean. So anyways, I reinstalled the oil pan and I filled up the oil again. I always like to fill up the oil filter a little bit with some oil before I reinstall it, just to make sure everything is primed okay. And I decided to crank the engine without the main ignition coil plugged in, so none of the cylinders will have spark, just to see if this thing will prime and get pressure. Well, I cranked and guess what? No oil pressure. Now, I don't really remember if I ever normally see oil pressure on the gauge during cranking, but you know what? I am going to be safe since I drained this thing out of all its oil. First, just in case I don't mess up the timing of the engine, I'm going to set the crankshaft back to 0 degrees. You get a wrench and torque on the balancer bolt typically to do this. Then unhook the spark plug wires, the vacuum hose, the spark coil, and so on from the distributor. And Sharpie mark between the distributor and the engine block to mark the timing. The way that you prime these pumps, you have to take off the distributor and spin the oil pump gear manually with a special extension tool. And I remove this bracket retaining the distributor and pull it on out. Keep everything clean and try not to let anything fall down into the hole in the engine block. And then pull out this gear and shaft as well. Then just stick the extension tool down in here. I used a hand drill to crank the extension. Now I have a buddy sit in the car, and with the ignition on but the car not running, go ahead and see if the oil pressure gauge works. The drill let a little bit of magic smoke out, but it did actually produce oil pressure. How much? I'm not sure. I should probably get a kit and test it. So that tells me that this is nice and primed again. Now time to put the distributor back. Just have to stick it back in here. Make sure it's clocked correctly so that you can fit this shaft and this blade back in, and then seat it all the way down and line your marks back up, then put the bracket back on it. Hook the spark plug wires, the spark coil, and the vacuum back up to the distributor. I'm not going to tighten the bracket all the way because I want to adjust the timing with a timing light. See previously in the video for the procedure on how to adjust the timing. The timing chain in this car is internal and under the front engine cover, so I can't really get to it or anything. Some more modern engines have a timing belt that can be replaced. A little bit easier, but this may be a source of noise, but typically if this happens, the car will run funny. It might not run at all. If it skipped a tooth or something, it'll run out of sync, and it could damage your engine very easily depending on what type of engine it is. If your clearances are out of whack from the previous step, then a total teardown and replacement may be in order. Quick tip though, if you go to a junkyard and you buy an engine, they do guarantee that it'll run, or else they will replace it instead of have a shop repair it. Typically this is going to be a lot cheaper. Just keep in mind that a junkyard engine will obviously have some pre-existing wear on it. One trick I use when unplugging stuff from the engine is I always put a piece of masking tape around whatever I disconnected and whatever it went to, and I label them with the same number so that I remember how to plug it back in. I always like to add a little bit of extra fuel additive if I'm going to store it too, just to make sure that the fuel stays stable while it's being stored. It's a good idea to run brand new gas through old motors and carburetors like this so they don't get gummed up over time. Now it's time to start the car back up again finally. Of course, watching your oil pressure again. You can actually tell if it's getting oil if you take the cap off of your cover and look under here and see if there is oil pooling up in the top of your rockers. And then be sure to check for exhaust leaks and any oil leaks as well. Before I put this away, I always run this thing out of gas so that I know that the carburetor isn't sitting there with extra gas in it that could become a thick varnish. I drained the old gas out because this thing's been sitting for a while. You just have to disconnect this hose at the bottom of the engine here. It's a mechanical fuel pump, and let it drain out. I get a straight nose vice grip and I clamp off the fuel hose supply to the carburetor, and I just turn the car on and crank it until it fires up, and let it run until it dies and runs out. And I crank it a few more times just to make sure that it doesn't fire anymore and it is all out of gas. All right, looks like that's the last it's all to give, so it's time to go back into storage. I also like to put my car on jack stands so that I don't get flat spots on the tires if it's being stored long term. And last, if you're going to be storing it long term, go ahead and disconnect the negative battery terminal. Well, that's it for this video. Please give it a thumbs up, subscribe, hit that notification bell, and I'll answer any questions in the comments.